Alright, we're going to be dealing with the basic understanding of all the functional groups in organic chemistry for the different families of the homologous series. We are just going to look at it briefly because a better understanding of them will allow you to quickly understand what we're talking about. So the number one is alkane. Alkane have a general formula CnH2n plus 2, where n is greater than or equal to 1. The first member of the alkene family then will be what? CH4, because if you put 1 here, it's going to be C times 1, 2 times 1, 2 plus 2, so we're having 4. And the name is what? Methane. The next one that we're going to be discussing is alkenes. Alkenes have a general formula CnH2n plus CnHn, where n is greater than or equal to 2. N is greater than or equal to 2. Now, the general formula, now we have to know that for alkenes, there have to be double bond, that's the functional group. Double bond between two carbons. There have to be double bond between two carbons. That will signify that we are dealing with an alkene. Whenever you see a compound that have double bond between two carbons, you know that you're dealing with what? An alkene. So the general formula for alkenes is CnH2n plus 2. Now an example of an alkene using the same formula, we can have C2H2 times 2, 4, which is what? Whenever there are two carbons in organic chemistry, we are talking about eth. So it's called ethene. The next one is we're dealing with alkynes. Alkynes have a general formula CnH2n minus 2, where n is greater than or equal to 2, and the functional group is C triple bond in between carbons. Whenever you see a compound that have triple bond in between two carbons, that is an alkyne. And example of an alkyne is using n as number 2, it's going to be C2H2 times 2, 4 minus 2, we have what? 2. So the name of this is called what? Ethine. Something that you should quickly know, in organic chemistry, whenever you see met, it means 1 carbon. If you see eth, it means 2 carbon. When you see pro, it means 3 carbon. When you see but, it means 4 carbon. When you see pent, it means 5 carbons. When you see hex, it means 6 carbons. When you see hept, it means 7 carbons. When you see oct, 8 carbons, non, 9 carbons, and dec, 10 carbons. So if we are considering our n as 2, we're having ethane. Let's say we are now using 3, it's going to be what? It's going to be propane or propene, depending on the family you're discussing. Are you with me? I believe you understand that. Okay, the next family we are going to be discussing is alcohols or alkanols. Their functional group is OH, and their general formula is CnH2n plus 1 OH, where n is greater than or equal to 1. So we'll be having, for example, CH3OH. Since it is 1 carbon, it is what? Met. We are dealing with an alcohol, so the name ends in "ol", so it's going to be methanol. So all compounds that you hear that end with "ol" are known as alcohols. methanol. The suffix is always what? Or. Alright, so you can try a few examples from carbon number 2 to carbon number 10 using these prefixes that I just lined out here for each of the members. If you are dealing with carbon number 8 in alcohols, for example, it's going to be what? Octanol. And you are going to apply this general formula. The general formula, if you apply it, is going to be what? C8, right? 2 times 8 is what? 16 plus 1, 17. Then you now add the what? OH. Okay, we're still going to deal with some drawing structures of all these different functional groups so that you'll be able to have a better understanding. So the next one we're going to look at, number 5, is what? Alkyl halides. Alkyl halides is just an alkane that has the presence of halogen inside of it. So we can represent it with RX. So it's going to be what? Something like a CN H2N plus 1 R plus 1 X and X here means what? Halogens. Example, we can have C2H5Cl. This is ethyl chloride, or you can call it chloroethane. So this is an what? An alkyl halide. So ethyl chloride. Right, number 6. Number 6, we're going to be having ethers. Ethers have a general structure. Sorry, I made a mistake here. Ethers have a general structure. R, of course, by now I believe you know what R is. O, R is what ethers look like. So an alkyl, that is 2 alkyls bonded with oxygen in their center. Example, we have CH3O CH3. This will be known as dimethyl ether. In other way, we call it methoxymethane. Okay, so the next one. Alright, so the next one we're going to be dealing with is aldehydes. Number 7. Aldehydes. They are called number 7. Sorry, that's a mistake. Aldehydes or alkanes. Aldehydes or alkanes. Their general structure or formula is RCHO. Can draw it better like this. Double bond OH. Aldehydes. Their functional group is majorly C-double-OH. This is the functional group for aldehydes or alkanes. That's the name. Example, remember we say R, so it's going to be any R exactly. So we can have C2H5C-double-OH. Right? So this is called what? Propanol. Why? Because we have 2 carbons plus 1 carbon. Make it what? 3 carbons. The mistake a lot of people make when they are dealing with compounds whose functional group has a carbon is that they always forget to count the carbon. Always add your carbon. It is also important to know that here N is greater than or equal to 1. That means the first member of the alkanals starts from carbon 1. So we can just add hydrogen here, now by having what? A methanol. That is an alkanal with 1 carbon. Are you with me? Okay, so the next one we are going to be dealing with as number 8 is ketones. Ketones. Sorry, I'm always making this mistake. Those ketones or alkanones. Ketones or alkanones. So the functional group for ketones is actually C-double-O, but there is a catch to it. There are a lot of compounds, organic compounds, that have C-double-O in their functional groups, and they are known as carbonyl compounds. So because of that, you need to pay attention very clearly here. So it has to be something like this. The carbon bearing double bond will be in between 2 other carbons side by side. As you can see, the carbon that is bearing double bond is in between an alkyl compound or 2 different carbons, right? So if it is not in this kind of scenario, we cannot consider it as a ketone. Do you understand? So for example, so C double bond O. So let's count the stability of carbon here. 1, 2, 3, 4. This carbon is stable. 1, 2, 3, 4. Let's put our hydrogen. And for this carbon, 1, 2, 3, 4. For this carbon, so it's balanced now. So this is propanone. Propanone. With this condition, you can see that the carbon that is bearing double bond O cannot be either at the both ends of the carbon. The carbon bearing double bond O cannot be here or here. Once it's here, it's going to be another compound. It can either be an alkanal or an alkanoic acid, depending on whatever is added to it. So the condition for alkanones is that the carbon bearing double bond, which is this one, must be in between 2 carbons. Are we together? Okay, so let us check for other examples. Let's say we have something like this. C, another C, another C, another C, another C. So this, we are dealing with how many carbons here? 1, 2, 3, 4, 5. So where can we put our double bond? We can put it here, and we can put it here, because these are the carbons that have double bond, all right? I can also put it here too. We can also put it here. All right. So when you're dealing with double bond, you have to be careful of the stability of each carbon. So let's deal with this carbon. For this carbon, we have 1, 2, 3, 4. For this carbon, we have 1, 2, 3, 4. For this carbon, 1, 2, 3, 4. For this carbon, 1, 2, 3, 4. So we don't need to add any hydrogen, but for this carbon, 1 only. So 2, 3, 4. In my previous video, I talked about the 4 arms of carbon and the stability of carbon. Carbon must have 4 arms for your organic structure to be correct according to organic chemistry standards. Alright, so the next one we're going to be discussing is number 9. We're going to be discussing carboxylic acids or alkanoic acids. So carboxylic acids or alkanoic acids. The general formula is RCOOH. Obviously, you should know what R is now. CnHn plus 1. So in this one, sorry, let me write it out because I need to hit the point. CnH2n plus 1 COOH. In this carboxylic acid, N is greater than or equal to 0. As n is greater than or equal to 0, C times 0 is what? 0. 2 times 0 is what? 0. Plus 1 is 1. So we're going to be having HCOOH. Right? The functional group for carboxylic acid is COOH. So anywhere you see COOH, it means that you're dealing with what? An alkanoic acid. Anyway, you see COOH, we are dealing with an alkanoic acid. So this is HCOOH is known as metanoic acid. Let's try another example. CH3, that's an R. Then we'll put the functional group. This is called 2 carbons. So it's going to be, sorry, I made a mistake. I should have written it here. CH3COOH is going to be ethanoic acid. Right? Ethanoic acid. Why? Because it has 2 carbons. It has what? 2 carbons. This carbon and this carbon. Right? Okay. So the next one that we're going to be dealing with, number 10. Number 10, we're going to be dealing with esters. Remember, we have dealt with ethers. Now we are dealing with esters. Esters, they have a general structure. R, C, O, R prime. That's how I like to call it. Okay, for esters, it has to undergo a reaction, and that reaction is a reaction between alcohols plus alkanoic acids to form esters plus water. A reaction between alcohols plus alkanoic acids to form ester and water, and this reaction is known as esterification reaction. RXN is the short form for writing reactions. This is esters. So example of an ester is CH3 COO CH3. And when we want to name esters, we name from the back. We name this acute compound here before we are naming it. So this is methyl, right? Then how many carbons are here? 1, 2. So we'll call it methyl. Methyl what? Let me change the color. So 1, 2. Methyl ethanoate. Methyl ethanoate. Okay. So we have a few more to go. Alright, so the next one we're going to be discussing is amines. Number 10. Notes that the hydrogens can be replaced by functional groups. They can be replaced by R. For each time it is being replaced, it's going to be something like this. R, let's say one of the hydrogens was replaced, it's going to be R, NH, R. Since both hydrogens is going to be R, N, R2. Right? Okay, so amines. Whenever you see N2, whenever you see NH2, it means you are dealing with amines, right? So the general formula is CN H2N plus 1 NH2. That's why I'm using R to present it. Example, we have CH3 NH2, and this is called methanamine. Methanamine. Why? Well, it has 1 carbon. So let's say we have something like C2H5 NH2 is called what? ethanamine. I'm going to deal with naming of structures of the different members of this functional group in my next video. Okay, number 11, so almost rounding up. Number 11, we have imides. Oh my god, I've made this mistake again. Imides, they have general formula CnH2n plus 1 COONH2. The functional group is NCOONH2. So the difference between amides and amide is that for amide, it has an accompanying carbonyl group which is COO. That is just the difference. So example, we have CH3COONH2, and this is called ethanamide, right? It's called ethanamide. Okay, so number 12, we're going to be dealing with nitrile, which is what? Which is RC triple bond N. This triple bond is different from the triple bond of alkanes. This triple bond is a condition that's been fulfilled when carbon is bonding with nitrogen. So we have triple bond. Example, we're going to be having something like this: CH3 C triple bond N, which is called nitrile. Ethanitrile. Of course, it came from the fact that we're dealing with two carbons here, right? So I believe that with this you have understood a lot. Try and go through this video once again and digest all that I've just taught in this video. See you on the next video. In the next video, we are going to be talking about drawing the different structures of the functional groups that we just discussed in this video. Thank you for watching this video. Do it to subscribe, like, share this video to your friends and loved ones. See you on the next one. Bye.